Hello friends, in this lessons I will show you how to observe the apparent triplet in this particular example. If you're not sure about how to calculate the doublet J value and shift value, just click on above link which will leads to the calculation of the J value and shift value of apparent triplet. So this is a special case of the doublet. So in last video I also explained this scenario when you have two proton here having same chemical shift and coupling constant toward this proton also same, you will get the absolute triplet. So there's no confusion here in this case. But if you have different chemical shift like A, B, C, then if you have two J value are same, then you have to chance to get the apparent triplet. So it is a special case of doublet. So sometime you will observe the n+1 rule is also fail in these examples. Let's dive into the example. So here this is the example of the dibromopropanes. So we'll say here four type of the hydrogen. One is the methyl group here, one is hydrogen here, one is hydrogen here, one is hydrogen here. Each proton has different chemical shift. So why we get this doublet of methyl group 1.8 chemical shift? Because this hydrogen split into this. So this hydrogen is little bit complicated. It observe the coupling of this one and feel the coupling constant of this one. This is a doublet of Quartet. So DDQ is this type of pattern, is a little bit complex. But these two proton has different chemical like 3.85 or 3.55. So there is a chance now we have three different chemical shift here, proton type of proton like this one. It's a two bond coupling, this coupling and this coupling is three bond coupling. So you will see observe triplet here, apparent triplet and one doublet. So this is a strongly focus on word nearly same coupling constant. So these two has two bond coupling HA and HB and C. I assignment little bit try to assign this spectrum. This spectrum lies here, this proton and this proton HBs lie here, and this is methyl is doublet and this HC is the Quartet. So always assign this type of the spectra very carefully. So one proton of C1, here this one is the C1, is 3.85 coming here. Another of the HB is 3.55. So the coupling constant of this proton and this proton has different. So that's why you will get here doublet. But one of this proton, the coupling constant of this one and this one is nearly same as the two bond coupling as well as three bond coupling. So when you have nearly same coupling constant, you will get the apparent triplet here. So this is the example. You can find a lot of example on internet, just also taken from this one internet. This is a example where we get the apparent triplet. I will repeat again, the coupling constant of this one and this one nearly same. But for this coupling constant here and this one is not same, not nearly same. That's why you will get the doublet. So this is an example of, again, I will show this in last lecture. These are three different protons and having doublet and apparent triplet. So please like and subscribe for this. I will explain the DDD and DDDQ and TD and complex more spectra, how to calculate the J value and chemical shift of that type of system. Thanks.